Hello friends, welcome back to the Dr. Tristos channel. I'm Dr. Tristos. Well, when we left off the last time, we had got our demo working very well, very clean program code. It's three lines, and one of those is a no-op in the body of the code, but yet we're doing a pretty big task. We're printing the output screen 2 times. But the boss was in again, and he was like, you know, when you have a macro for UART0 and then you have a macro for UART1, and the company's talking about expanding, and we're going to make this multi-user, and we're going to have maybe 12 or 14 more UARTs, it's going to get pretty cumbersome. We're going to have so many macros, different macro statements, that it will be really difficult to maintain all of them. So you realize that the manager is right, and reviewing your help files, you can have conditionals inside the macros. And if we can have conditionals inside the macros, they can act upon the inputs to the macro. The inputs being here, as for example, in our earlier example, we had 2 inputs to the pump macro. We had screen and term, 2 separate inputs. So if we can have conditionals that act upon inputs and other things to the macros, let's look at our test ready. Right now we would have to have a test ready for each individual port, each individual UART. And if the company expands our system and we have a dozen more, we would have a dozen. So let's change this a little bit. Test ready 0. We can just take that off and make it, test transmit ready. That's the macro for that one, isn't it? Oh yeah, so sorry. Leave this unchanged until, let's get down here to the other macro. Here's where we want to be. Here's our test ready, transmit ready macro. It has no inputs. But if we're going to make a conditional and macro, and it output to the UART that we want to output to, we are going to need to know what that UART port number is. So we're going to have at least one input, and we'll call that input UART. It will have a numeric value of which UART we're dealing with. So, with that being said, let's come down here. We're going to leave this label intact and come over and call it equate to the dollars, to the program counter right here. And then we're going to begin our conditional. If UART equal 0, then we're going to execute this instruction. And we always have to end a conditional with an end if statement right here. So if UART equals 0, then we're going to do this input instruction. An input from UART 0 line status register. You got that? Alright, we're going to save us some time. Like I've said before, good programmers copy, cut, and paste. And we're going to put this in again right here, because we want to now create one for UART1. If UART equal 1, then we want UART1 line status register. There's a couple of different ways we could go about making one macro that covered multiple ports. This is one way that we could go about that. So we're still going to test once we input the value into the accumulator from this port. We're still going to be testing bit 5. Doesn't matter whether it's UART 0 or UART 1. We're still going to be branching back here if the UART is not ready. If the UART is ready, then we'll fall through and end the macro and continue with code. We can now do away with the 0 on here because this is test ready for any UART. We just need to test ready and provide the input, which is the UART number that we want to test ready for. Okay. So hopefully with the blank lines we make this this text kind of readable here, and breaking it into segments, and this should work fine. So we can test ready for any UART. Well, now let's look at our pump. We already have two inputs to pump: the screen address, or the address of the data, where to begin to start pumping, and what character to terminate on. But I guess we're going to have to tell it which UART we want to send this out. So we're going to add an input called UART, and we'll add that to the beginning. So now we begin our macro. Our objective is to have one macro called pump. We don't have to tell it 0 or 1. We're going to do that over here on an input. It'll be telling it which one UART we want to send this out. So loading the H&L register pair is something that's common to both, to any UART that we're going to send it out. So we leave this unchanged. We're no longer testing UART 0, we're testing any of them. So let's just remove the zeros. And here again, I corrected myself on my last video. We can put the $sign, and we don't have to use numbers. We can use meaningful labels. What the assembler is going to do is add an _1 for the first time this label is used in a macro. Then when we repeat a macro and we have this label again in the assembly, it'll be _2 that precedes the test ready. So each one will have a number assigned to it, but that will cause it to be a unique label in the assembly. They'll just each have a unique number added to them. But it allows us to use more meaningful labels. I used numbers before because I believe it's the Tristos assembler that uses numbers for labels inside of macros if you want them to be private to that macro. Anyway, let's get back to, we're going to continue with what we're doing here. Instead of 2, let's call it no more. That's kind of meaningful. And so we got now we have to test ready. And if we remember, we have an input to test ready now. We need to tell it which UART. And so we had the UART at the beginning as an input to this macro. That will be the same input that will then pass to the embedded, to this macro, calling this, invoking this macro is embedded in the pump macro. This input is shared. So in other words, they're not independent. They're going to be shared. So if the macro has, the pump macro, the input to it is going to pass into the macros internal to that, and that allows us to pass the same data. That way we can pass data into the embedded macros. Otherwise, you wouldn't be able to communicate with them. So now we're going to tell it which UART to our test, invoke that macro when it's all ready and it works. I need to check myself real quick, but I think we might have something that'll run here. Except now we come down here and we say pump. Well, we're not going to tell it which UART anymore. By having a pump 0 and pump 1, we're going to say pump to UART 0. And I'll tell you what, we're going to pump to UART 1 also. So now when we run this, our simulator allows us to see both UARTs. And we should have this screen on both. Let's go ahead and the same screen on both. What do you know? No syntax errors. So here you go. Here is the example demo. Looks like we printed it 2 times. Okay, I know what we didn't do. We didn't finish our programming over here. We got another bug, don't we? I don't think we finished everything we needed to. We told it if it was UART1 to use the UART1's line status register. We don't have a UART1 line status register programmed up here. So again, we're going to copy code and put it in here. And I just happen to know that the address for 1 is Delta instead of Charlie. So Delta 0 and Delta 5. And we're going to change this to a 1. So now it should find the correct ones. And let's try it again. We built with no errors. And there again, we output the same thing twice to the same screen. What did I do wrong down here? Yeah, okay, stupid me. I'm pretty sure that here, I didn't add the conditional here. We did the conditional in testing, the status, but then when we're doing the output, we're doing the output to the same UART both times. So if I can type here, If it's UART 0, we'll use this code. That's the end of that conditional. Now, like I've said before, good programmers copy and paste. We'll copy that code and change it to UART1 transmitter holding register and change it to saying if we are UART, if the person is wanting to send the output to UART1. And so now we see that we should be testing, depending on which UART. Down here, test ready. We have conditionals, depending on which UART you tell me. So I want to point out something important here. These are the two internal UARTs, and their line status register bit 5 is the tells you if you're ready to receive a byte to transmit. If you were to build additional UARTs and add them on, if you used a UART address, you have your own UART address you've assigned, as long as you use bit 5, all you would have to do is create a label, UART 12 underscore line status register. UART 10, where we at here? Transmitter holding register. You could have additional conditionals. But the point is, you would only have to create labels with the address of your custom-made UART board and having a bit 5. I also want to point out that the macro is somewhat universal in that these would not have to be a serial port. As long as you had bit 5 indicating the status to receive output, this transmitter holding register, that could be a parallel output register also. That could just be an 8-bit parallel output port that goes into some other project you have. So the important thing is you're just able to, by modifying this macro and using the equate statement, set up an address for any custom UART or parallel output port that you want to use. If you wanted to have one macro that could write a block of memory to that port. So now we have conditionals there that handle both. Let's see what happens for us. We're going to load and go on that. Hopefully I didn't make any syntax errors. We see it prints one time for UART 0. And there's UART 1 and we have the same thing. Well, the boss said that we always have to verify our code. So to verify our code, we need to do testing. And as like I said, programmers copy paste. Let's create a new block of text to output. And we'll call this my screen 1 and my screen 0 now. We're going to change the labels on that. So now we have two different hello worlds, two completely separate blocks of data. And this is an example of CDS2 using UART 0. This screen is an example of using UART 1. So we definitely know if we see the UART 0 or UART 1 which data block is being printed. And we down here we tell it my screen 0 and my screen 1. And if I did not make any syntax errors here, this should compile and go. And on the right, we see UART1 is displaying the message of using UART1. Which that matches up with the message that's embedded here. If we switch to UART0, we can see that matches the message here, so we know which statements that. So, friends, I want to point out this development system again is free for the download from Zilog.com. And you can do a lot of testing of code and learning how to use the EZ80 and the development system. And if you're someone that's just learning, maybe we'll get into some of this code later, but you want to execute an instruction and see how the condition codes and the F register changes and things. Right here is all your registers. When we stop, here's the F register, your flags register. It has a 4-2 hex. And we can break that out in binary and look at it and see which bits are set, etc. There's some registers on here you won't recognize. But if you notice, we haven't really had to program. We've been programming this just like a Z80. At this point, I don't think I've used really anything but Z80 instructions. So, I hope this has been of some use to you, and it answers some more questions, and it shows the power of macros. So now we have a macro built to do in our projects. Anytime we want to send a block, a block of ASCII characters out the UART to send messages, etc., and have some way to terminate that string, so we can send a block of several sentences with carriage returns and line feeds, etc., and terminate with we'll use an end of text to terminate the block, or we could even terminate using some other. And there's reasons that you may want to do that. To use other characters or ASCII codes to do the termination. Let's see. Again, now we could definitely use some commenting up here, and why don't we go ahead and do that, because you should always be commenting your macros. Later you'll go to use this and you'll think, I don't remember anything I did here. I remember that day, but that's all I remember. I don't remember how this macro works. So that's why we're going to do just a little pump macro with 3 inputs. And also you might normally let's say start off a macro with a date, and we'll put 3/26/25. And I'll put my initials and this macro is for an example video. So we have a short little description there of why we have this macro, what it's for. And we tell people that it has 3 inputs. And then so since we're typing comments, we need to use a semicolon here. UART number for output, and then we'll tell it is a pointer. And then lastly, we have term. Now, I also want to point out that we could here terminator, term. Someone says, well, you know, I want to be able to terminate on, if we look down here, it does a compare. We used, what do we use here? etx.asc. You could also, since that's going to output, let's say right here, it's a 0, 3, right? So you could also just put 3. It would be the same thing because when it assembles and runs, it's going to compare a 3, which is the same thing as what's happening with an ETX, something that's been equated to 3. So how do we know that? We'll wrap up here. There again, we'll go to our output, debug, get the output listing. And we can see here, when we come down and look at our macro, that pump, UART1, my screen 1, with a 3 is the terminating character. Here's load H&L with my screen 1, doing the test ready on UART1. So once the UART becomes ready, we're going to fall through. It's not UART 0, so if you know, we will, let's see, where are we at here? Okay, so when we get down here, comparing 3, right here's where we're comparing the terminate character. And you can see that it's a 3. And it assembles over here. FE is the opcode for compare 0, 3. That's going to compare to the accumulator. Let's look up here in the other macro where we used ETX. And it's saying in the assembler, compare etx.ascii. And let's look how that assembles. It's the same opcode, of course, and look at there, it's a 3. So the equate is the same, but as you can see, it's more meaningful to have something like etx.ascii, my own notation system, than to just have a 3. Some people can argue the other way. They say, well, I have to go look up and see what an ETX is, what its value is. That may be true, but you can look, and if you're needing that information, it'll always be in the assembler output or in the compiler, the source code input. I hope this has completely cleared everything up for you. I don't know how, I'm not sure anybody can follow me, but I just wanted to give some examples of using the development system as I move on to using it for something more complex, such as assembling a project or TrisOS. We're talking 14,000 lines, over 14,000 lines, I think it is. So I wanted to cover some of this in advance and try to get anybody that's not using the ZDS to maybe give it a try. It's come out of the Z80, it's not that hard. If you're coming from the Z80, you'll be able to to migrate right over to this. And then you'll think, oh, this is so much easier. Okay? Thanks a lot. Many thanks for watching. I hope to see you back here again soon.